Today we're looking at section 9.3 on perimeter, area, and circumference. And in this section you'll see that we have a lot of formulas that we have to work with. And hopefully you've seen most of these before in algebra or geometry class. And the two ideas we're working with are perimeter and area. In the case of a circle, instead of perimeter, it's called circumference. And then, of course, the area of the circle. So we begin with the triangle. And unfortunately, again, my drawings didn't transfer, so I'm going to add these in as we go along. And we have a height, a base, and a side C. So the perimeter is height plus the base plus the in this case the side opposite, the hypotenuse as we refer to it. And the area of this triangle is 1/2 the base times the height. So 1/2 this base here times this height. Now what you should note is that actually the area of a triangle comes from the area of the parallelogram, which we will look at in a few minutes. So I may come back to look at the triangle after we take a look at the parallelogram. So the perimeter of a rectangle, this is one you should know from, hopefully, from high school and actually elementary school. The perimeter is twice the length. We have 2 lengths and 2 widths, so twice the length plus twice the width. The area is found by multiplying the number and the length. Basically what we're doing is counting the number of units along the length and multiplying it by the number of units along the width. And what that gives us is the number of 1 by 1 square units in the rectangle. For a square, of course, a square is just a specialized rectangle. All of the sides measure S, so the perimeter is S plus S plus S plus S, or 4S. The area would be S squared, S times S. The area of a parallelogram here's the height right here, and here is the base. Turns out this one also measures B, and we could extend this here and we would also have an H. Now what you'll note is if I cut this little triangle off at this end and put it over here, what happens is I get a rectangle that measures B by H. So the area for a parallelogram is B times H. And it turns out for a triangle, if we divide this into 2 triangles, each one of them will have an area of 1/2 base times height. So the 2 triangles, actually, if you do cut them out from a parallelogram, the 2 will be equal. So that's where we get the formula for the area of a triangle. Okay, now we have our trapezoid. Okay, trapezoid, remember, has 2 sides that are parallel. And every time I want to emphasize something, I need to go to my highlighter. The 2 sides that are parallel are called the bases. The height is actually the perpendicular that drops from one base to the other. So this is actually H way over here. And the way we find it, actually, the trapezoid can be divided into 2 triangles. And one triangle, the one at the top, if you visualize flipping it over, the area of that is 1/2 capital B times H. And the other triangle is 1/2 little b times h. So to get the area of the trapezoid, we want to add those That gives us 1/2 little b h plus 1/2 big B h. We have a common factor, 1/2 h, that we can take out. That leaves little b plus big B. So that's where the formula comes from. So we want to find the sum of the parallel sides, and we need to know the height of the trapezoid, and we take 1/2 that height and then times the sum of the bases. Okay, our last figure is the circle, and as I mentioned earlier, we talk about perimeter with all other figures on the previous page, but in this case, for the circle, the perimeter is referred to as the circumference. Okay, and this here is the diameter. This would be the radius, and of course the diameter is twice the length of the radius. So we have two formulas for the circumference. Circumference is pi times d, or since d is 2r, or 2 pi r, so we can write it in either form. The area of the circle is pi r squared. And our book goes into quite an explanation of where this formula comes from. If you look at the bottom of page 558, what they do is they take the circle and cut it in half, so you have two semicircles. And then what they do is they cut, all right, so here would be one of your semicircles. They cut from the center out almost, not quite to the edge. Okay, and then they fan that out, and you can see how they fit the, you do that to both pieces, and then you kind of flatten them out, stretch them out, and fit them together to create something that looks like this. And basically what you have, this part, since the entire circumference is 2 pi r, this part would be pi r, and of course this is the radius. So we can see we have somewhat a rectangular shape, so pi r times r would give us pi r squared for the area of the circle. So mostly in this section what you're doing is just using the formulas to find the perimeter, the circumference, or the area of a given figure. So in the next segment we'll take a look at some sample problems from the even numbers in the textbook.